I appreciate that, and I am certain you want to hear from other people than me, so I'm going to be fairly quick in trying to set a wee bit of the scene for a couple of very talented young people to present the hard work that's actually being done. This is the scientific team that's part of the Sheep Gems project. And I raise that because this is a wonderful consolidation of expertise to try to address a very complicated set of problems. And our strength is because of the people who are up there on that list. But equally, if perhaps not more important, part of this project is all about educating and engaging our next set of scholars who will be working with you to take these ideas forward. So we have a large number of students who are engaged in various levels of work. And notice about half of these students are what we would call domestic students. About half of the students are international students. That is science today. And we need to be sure to embrace and endorse the fact that moving forward as an industry, we need to work collectively with the expertise that's available to us from around the world. Today, we're actually going to hear from a couple of these students, Artur and Hilal, who are the two students who are actually funded through the Sheep Gems project. The rest of these students, we're funding through every which way, including begging, in order to be able to pay for their stipends and so that they can eat and live in a warm home. So anytime that you wish to give us money, we would be happy to take it and enlarge that list. All right? But before I turn it over to Hilal, let me remind you of what we're trying to do with this Sheep Gems project. So the rationale is based on this. We have lots of breeds spread across the country in a whole variety of geographies and climate. That's the nature of our industry. And therefore, breeding animals that can perform well in these different environments is a key feature of what we need to do as sheep producers. We need them to be robust, and we need them to be climatically resilient. And it's a real challenge to our industry. These are some statistics. Nearly 44% of ewes in the U.S. are culled prematurely for reasons other than age. That's a huge cost if we think about needing to replace animals that we'd rather not replace. Approximately 7% of the total U.S. lamb crop dies each year from non-predator related causes. They're not earning us a cent, and there's a well-being issue associated with those losses. Clinically healthy ewes that have a high somatic cell count, I'll get it out, have a real economic cost to us. Losses of $19 to $32 per ewe, even though they appear to be healthy. Huge consequence. And more than 20% of the mature ewes in our commercial flocks fall into that category. So these are real challenges that we need to think about in creating efficient, animal-friendly, effective production systems. So the Sheep Gems project is designed to think about some of these additional features that some of the young guns were raising earlier on. We're interested in defining what we call robustness and climatic resilience by beginning to measure traits that we don't currently include in our genetic evaluation. Things around udder health, lamb survival, gastrointestinal parasitism to a greater extent, ewe longevity, which I have tremendous concerns about, and thinking about them in the context of the environments in which our animals are producing. And the reality is, as has been raised, is although I think many of us think these things are important, they're not part of our current genetic evaluation. And so if we want to be encompassing and to move our industry forward, we need to do better than that. We need our breeding objectives, our goals that Dr. Murphy very nicely explained earlier, to capture more things about our animals to make our industries effective. And so Sheep Gems, and the name comes from these four components, is designed to think about systems of production that allow us to think about robustness and climatic resilience. It's about the genetics of our animals. It's about the environment. By that I mean weather patterns, geographies, altitude, precipitation. It's It's about how we manage our animals and about some of the social implications of what we do as sheep producers. Now today, we're not going to talk about all of that, or else we wouldn't ever go home. And instead, what we're going to do is talk about two elements of this project. One relates to how we're thinking about describing management practices in your flocks to deal with that component of this system, and Hilal will introduce that, and how we're thinking about efficiently designing genomic evaluation programs to get the best return on our buck on investment. A huge issue in small ruminants is the cost of genotyping relative to the value of the individual animal. Now, typically, I get to stand up here and take all the credit for what they do. Today, I'm not going to do that at all, and I'm going to turn it over to them to present. So let me first introduce Hilal. Home is originally in Turkey. She did both a bachelor's and master's degree at EG University, first as a general, the second in feeds and animal nutrition. They didn't have an animal breeding program for her to attend at that institution. And to me, that's great for us, because if we want to think about the overall environment that our animals find themselves in, having someone with her expertise that knows something about feed and animal nutrition, which I know absolutely nothing about, is really a valuable component of what we're doing. She joined Colorado State University for a Master's of Science in Animal Breeding, and this is the title of her master's thesis, Genetic Relationships Between Ewe Longevity and Foot and Leg Scores in Sheep. When I saw that when she applied to join us at the University of Nebraska, I did double flips, which I don't do very well anymore, because those kinds of expertise really relates to thinking about the overall fitness of our animals. So she comes extremely well prepared to be part of our program. And with that, I'm going to turn it over to Hilal.
Thank you, Dr. Lewis. Hi, everyone. Like Dr. Lewis mentioned, I will talk about the producer management survey today. But before doing that, I want to explain why we need it. And I will use this famous equation, and Dr. Lewis already explained it in the morning. And my equation has one more thing, which is management. As you know, phenotype is the thing that we directly observe from the animal. It can be weaning weight, body condition score, or fecal egg counts. And we know that it's the product of three important things: genetics, environment, and management. And in animal breeding, when we want to select for better genetics, we want to parse out the genetics from environment and management. To do that, we have fairly easily access to the climate data from the various weather stations, but there was something that we are missing in this equation, and it was the on-farm management practices. And the only way to obtain this was just asking the producers. So we decided to do that, and our aim is combining climatic and management information to more robustly define production environments. And according to Rowan and his friends' study, we know that in US, there is at least 9 different climatic regions, and we also know that they are subject to a change. According to climate simulations, by 2050, climate in many states will be like southern states today. As a sheep lover, we want to keep the sheep industry alive, and we want to prepare our animals to those changes. So we designed a survey which includes several sections like general management, such as labor input, and parasite management, lambing, other health, culling, feeding, and climate adaptation. And again, our aim is combining survey response with the climate data and define production environments. And at the end, this will help us to identify sire families which are better to able to cope with environmental challenges. And the target breed groups for our survey is NSIP recorded Katahdin, Polypay, Rambouillet, Suffolk, and Targhee breeds. Although we are still collecting responses, I want to present the current response rates for each breed. In the figure, you see 3 bars, and the first bar is gray one, represents the actively recording flocks, and this number comes from by looking at the weight data submission in 2020 or after 2020. For Katahdin, it is 106, for Polypay 57, for Rambouillet 19, for Suffolk 29, and for Targhee it's 31. And I sent the survey invitation email to those producers, and the second bar, which is dark blue one, represents the producers who responded my email, and the last bar represents the number of producers who completed the survey. We are still collecting responses, and I need your help to improve those numbers. Due to the time limit, I won't be able to present all the results, but I want to give you example questions, and these questions will help me to explain why I asked those type of questions in my survey. And I will start with the climate adaptation section. In this section, I asked a question like this one. Do you provide additional supplemental feed when the weather is cold? 79% of our survey respondents said that, yes, they are supplementing when the weather is cold, although 21% said they are not providing anything. I asked a question like this because it is very important when we want to identify the real climatically resilient animals. If you are providing extra food when the weather is cold, I may not see a big change in the weight of your animal. So in poor feeding conditions, this animal may behave different than what we expected. So I am asking those type of questions. Another question from the same section, and it was about housing structures. And as you know, housing is very important on the animal's performance. And I asked this question for 3 different periods: during wintertime, during summer, and for lambing. And you may also imagine that the animal who was born under a structure with 4 walls is very different from an animal who is born under no structure or in a forested area. So my survey includes those types of questions. And another question from parasite section. And I asked the producers if they follow any of them as their internal parasite control program. For example, in that one, if you are removing your animals from pasture during the high times of infection, this is something that we need to consider when we are evaluating your animal's genetics. Or if you are changing the lambing season to reduce the risk of high parasite infection, this is another thing that we need to consider when we are trying to identify resistant animals. And another question from feeding, and I asked that if the producers provide protein and energy supplements to their flock, and if they are doing that, how they are doing that. In the question, there was some sections like if you are providing in a self-feeder, it is very different from providing on the ground. And again, if you are providing the supplements on the ground, this may be a reason that you are seeing high parasitic infections. So those were some of the questions that I asked in my survey. And now time to interpret my survey. We believe that this survey will provide a snapshot of how U.S. sheep breeds are currently managed, and it will help us to parse management from the phenotypes to better identify genetically robust and climatically resilient sire families. And if you are an NSIP member, and if you are raising Katahdin, Polype, Rambouillet, Suffolk, and Targhee, please contact me by email to contribute this research and how to improve robustness and climatic resilience of U.S. sheep breeds. My email address is on the screen. Please reach out to me. And thank you for listening. Before leaving the floor, I want to introduce my colleague, Art, statistical methods for prediction of genomic breeding values in the U.S. sheep breeds. And he began PhD studies at the Purdue University in August 2022, and he will give a talk about the impact of genomic information inclusion in the genetic evaluation. The floor is yours.
So thank you very much, Hilal, for the introduction. So first of all, I want to say that I was quite happy to hear that genotyping is a very important thing for you guys, and we are going to talking about a little bit about that. And also accuracy, the concepts and what is accuracy. We have been discussing this since yesterday, so I find quite useful for this presentation also. So before we getting started, we have some research questions that we want to answer here for this presentation. First of all, do errors in the pedigree data impact the accuracy of estimated breeding values that we are calling here EBV? And also, second, does included genotypes improve the accuracy of the EBVs in sheep populations? So before we start to answer those questions, let's try to understand the big picture of what we have currently in the industry, now in the NSIP, for certain breeds. We do have the estimated breeding values using just the pedigree information. It's well known. All producers already use this to select their best animals and to also make progress over time. But one of the assumptions that we have on these models or on this current genetic evaluation is that, for example, let's imagine that we have these full siblings here. Their relationships will be exactly 50%. So they are sharing 50% of their material. And what will happen if we include the genomic information on the genetic evaluation? First of all, we're going to have the GBVs that we always call genomic enhanced breeding values. And the main differences, including this genomic information, the DNA information, their relationships will be no longer 50% anymore. We can better account for this and could be higher or lower. But there is we still have a huge problem with the genomic information and also the genotyping. It has a higher cost compared to the animal cost that you guys are selling. So we need to make sure that we are genotyping the right animals, the right proportion of animals to improve our gains and reduce our costs over time. So for answer those questions, we simulate a sheep composite population mimicking the flocks and regions here in the US for 4 reproductive cycles, or years. At the end, we get 20,000 post-weaning weights, phenotypes, 23,000 animals in the pedigree, and 20,000 animals genotyped with a median density panel that we mentioned around, previously we mentioned that it's around 50,000 SNPs. For comparing these accuracies that we mentioned, we had some scenarios, and we are comparing here proportions of missing pedigrees. We are also including this in these comparisons, different proportions of misidentified sires, and also different proportions of animals with genotypes. These two together here, missing pedigree and misidentified sires, we are calling pedigree errors. In other words, what is the impact of having these different missing proportions of misidentified sires and different proportions of genotyped animals, in the genomic evaluation. So first of all, do errors in the pedigree data impact the accuracy of EBV? And let's look for this graph in parts. The first one is, let's keep the misidentified sire proportions equal to 0 here, and just increasing the missing pedigrees. As we increase the missing pedigrees, we can clearly see a pattern here. The accuracies go down, as expected. But now, let's compare having the missing pedigrees as 0%, so we are not having missing pedigree information there, but we are having higher proportions of misidentified sires. And here the proportions are always 0, 5, 10, and 20%. Again, as we increase the misidentified sire proportions, we do have a reduction in the accuracy of the estimated breeding values. And this is quite straightforward because independently of what we have, we're going to have a decrease on the accuracy, and we do not want that. And as you can see, independently of the scenario that we have with misidentified sires or missing pedigree information, the patterns are the same, so the data is quite consistent. And what if we want to say, what is the most impactful in the genetic evaluation? Is missing pedigree or misidentified sires? And here I highlighted for you in red, and we can see that missing pedigree has a higher impact on reducing the accuracy comparing to the just misidentified sires. So the answer for the first question is, only 5% of either misidentified sires or missing pedigree could proportionally reduce the average accuracy of EBV by 12%. And this is a considerable amount, and we need to make sure that we are accounting for that. Okay, and what is the way of accounting for these possible errors in the pedigree? One of the ways, as we have been mentioned a lot, is genomic information. So for this matter here, we are considering a genomic information. We are including genotypes in our evaluation. In the x-axis, we have different proportions, 5, 10, until 100. And in the vertical axis, we have the percentage change compared to the current genetic evaluation without errors. This is very important because if we have an increment here, this increment is related to the current genetic evaluation considering no errors, okay? That's why we have perfect pedigree. So it's quite clear. As we increase the number of genomic information, the accuracy goes up very quickly. Just 5% was able to increase more than 5% the accuracy of the estimated breeding values. And this is a considerable amount also. Another important thing is, with 100% of the animals being genotyped, we have an increment of almost 50%. And this is also a very considerable amount. So the first answer is, with only 5% of the animals being genotyped, the accuracy of EBV proportionally increased by 5% in a scenario with a perfect pedigree. This is a very important key component of this one. And the second one, as I mentioned, with 100%, we have almost 50% of proportional increment on the accuracy of the breeding values. And now, let's see almost the same scenario, but including misidentifying sires. What is the impact of genomic information if we have errors in the pedigree? In this case, the errors that we are considering is 20% of misidentified sires, I'm sorry. Here, just for you to make sure that it's clear for everybody, we have a scenario without errors, or we have a scenario without genomics. Here is the first component, without genomics, but we do have 20% of misidentified sires. And what happens with the accuracy? Goes down, because we do not have genomics and we have a lot of errors. And again, this is compared to our baseline. And what is our baseline? The genetic evaluation that we currently have without errors. So including errors, we are expecting to reduce the accuracy. And the turning point for us, including genomic information, is 15%. What that means, with only 15% of the animals being genotyped in the genetic evaluation or genomic evaluation, we overcome these losses due to the errors in the pedigree. And this is also very important. And again, only 15% of the animals genotyped, with only this 15%, the proportional increase in accuracy overcame the accuracy losses due to misidentifier sires. In this case, 20%. And again, with 100% of the animals being genotyped, the increases goes to up 40%, 44 in this case, even in a scenario with misidentifier sires or pedigree errors. So the first answer is, yes, even a small proportion of misidentified sires and missing pedigree information can reduce the accuracy of breeding values by a considerable amount. And this is very important, because this is what we currently have. And does including genomic information improve the accuracy of breeding values in sheep population? And again, yes. Genomic information will be able to correct for pedigree errors and also increase the accuracy of breeding values in our sheep populations. So some interpretations here and like take-home messages. Even with a limited number of animals genotyped, Genomics was able to improve the accuracy of EBV and correct for pedigree errors. This is a very important message. And the second one, continued genotyping is crucial for future improvement and increasing genetic gain over generations or over time. And that's it. Now I'll turn back to you, Dr. Lewis.